Okay, so we have the second speaker, Vlad Trifa, also from Switzerland. He's the Chief Product Officer for Ambrosus, and he'll be talking about how blockchain can be used with Internet of Things.
Lovely. Okay, cool. All right, good morning, Sydney. That's it? All right. Come on. All right, so I wanted to talk a little bit about the work we've been doing in this space. We come from the IoT world. I've been working for 10, 15 years in that space. And when I've seen like the whole development, the whole excitement around blockchain, we found it was really interesting to start see how the two fit together, what's the cool stuff we can do by combining the two together, and how can we essentially make businesses, cities, everyday life a little bit better by combining the two. So, you know, the starting point for our work was just reading the news, really. So you see every day there are people getting sick, some people are even dying because they are eating food that's unfit for consumption, because they are consuming counterfeit medicine and stuff like that. So we were wondering, I mean, why in 2019 that's still happening? I mean, all the progress in technology and supply chains and the food we eat seems to get just worse and worse every day. So how could we fix this? How can we use those new cool technologies to make that a little bit better? So the starting point was really realizing that there's a little love story developing between blockchain, Internet of Things. There are some very nice overlaps. And our work was really, how can we bring the two together to make each other much more interesting, like each one of those technologies? So our vision was first by using trusted sensors, so really small embedded sensors that we can put around food, around packages. We can start measuring the state, we can measure all sorts of real-time conditions around it, and combine that with any distributed ledger technology so we can record all the data around products in a very trusted way, so that they can be shared with trade partners, they can be shared with the end consumers, just like us, or they can be used also for auditing and even more cool things such as triggering smart contracts payment for a payment and stuff like that. So, you know, the solution is essentially how could we use blockchain to build this solution where we can track end-to-end all the products all the way to consumers. So, how do we build that? Essentially, there are some few challenges that still haven't been solved, not just in the blockchain space, but in general, to make such a system a reality. The first, which is quite important, is just the volatility in crypto prices going up, down. That's really a no-go for many businesses, because if they use any system, they need to know how much it's going to cost at the end of the month. So if you tell them, well, it depends on the markets, depends on speculation, that's just not going to fly. So we need to find a solution to give them access to such a service so that it's stable in US dollars or any currency they're using. The second, even bigger problem is essentially that there is no single standard for IoT. I mean, there are like hundreds of them, sure, but there's not one single standard that really defines in a clear, simple, universal way what data is, regardless of the device it comes from, how do you model temperature, how do you describe properties such as location and stuff like that. So how can we connect all sorts of devices if they don't speak the same language, essentially? The third one is essentially, you know, scalability, performance. When you read all those reports around 50 billion devices connected by 2022 and stuff, how can you collect, how can you manage those huge amounts of data? I mean, it's essentially terabytes every day of data. How do you store that? How do you secure, how do you connect that? How do you interface it with the blockchain? The other issue as well is end-to-end security is very, very rare in the IoT world today. Like essentially, the vast majority of IoT solutions, they rely just on encryption across hops, but there is no sensor side signing. So essentially, you have absolutely no way of proving whether some temperature measure really came from the sensor or if it has been tampered with somewhere along the way. That's a big issue that also needs to be solved. And finally, just the development tooling, the developer tooling, all the software SDKs, that makes it a lot easier for people to just very quickly build, scale, operate their apps. So that's essentially what we were trying to solve. So at Ambrosus, we try to combine and make IoT and blockchain great again. So we essentially built Amnet, that's our core solution. So we've essentially announced it last year at EDCON, and now we're gonna go live in a couple of days with it with our mainnet. So we've had a testnet for a few months that we've been improving testing, and we are about to release that. So essentially, it's a decentralized middleware to build enterprise-grade blockchain's application. And it's essentially the layer on top of blockchain that offers a higher level interface that makes it a lot easier for businesses to start integrating with blockchain technology and leverage real-time data from sensors. So the first thing it offers is really this universal data model. There is a very simple REST API JSON model that describes how can you model anything in your application. And instead of using the lower level transaction wallets type of metaphors, we have a higher level data model, which is essentially assets and events, and everything can be mapped just as assets and events. It also supports private and public data, and that was something very, very important because lots of businesses, if you talk to the big food companies, they are not yet there in the mentality where they really want to share all their data. So they understand they have to do it, they understand they have to get there, but they really want to have some sort of control initially over the data because that's competitive advantage for them in a way. It supports stable fees for using the system for the same amount of data. It's entirely governed by crypto economics, so all of the logical of the coordination between the different actors happens via smart contracts, and it's fully open source. So if you look at the stack, let's just dive a little bit deeper in how we architected that. At the core, there's the blockchain layer. So that's essentially a permission POA Ethereum network that we're using. But on top of that, we've built our own distributed storage solution, which I'll describe in a second. And it's essentially an incentivized storage where you can put metadata and huge amounts of data without necessarily putting it all on the blockchain itself. And on top, of course, the APIs, gateways, all the SDKs to make it very, very easy to build your applications and especially your dApps. So how does that work in practice? The first component, one of the central piece we've built is essentially, we call that the Herrmann node. It's essentially a gateway, a simple service. It's fully open source, so that's the code. It's on our GitHub. You can run it, download it. And what it offers is very simply a REST API with this data model and API I was referring to before. It has a local database, so all of the data from sensors, from your applications, machines, scanning equipment, enterprise systems, you can just send it to that place. But what's interesting is that every single data you enter in that database, what we do is we take the metadata of that data, so such as timestamps, such as who has signed the data itself, so the public address, the hash of the data itself, and we put that in a big file that we call a bundle. And then we use the hash of every single entry in your database, if you want, to create a Merkle tree that allows us to prove every single entry modification in your database. So anytime when you want to take this file and you want to commit it, essentially, what we do is this Hermes gateway also has a blockchain client, and it calls a smart contract function, which says, I want to upload this bundle now. And you can upload as many bundles as you want, knowing that in one bundle you can put right now until 16,000 sensor reading in one single smart contract call, essentially. You pass the hash, the root of your Merkle tree in that function. You pass the URL, so where anyone can download the bundle, because it needs to be publicly visible, and the duration, like how long do you want the network to store the bundle for a number of years. And the fee you will have to pay with this transaction is going to be a proportion of a base fee, which is stable in USDs, as I mentioned, and the duration in number of years, essentially. So as soon as you send that transaction and it gets into a block, what happens is you have those community nodes, atlases, that are run by anyone can run those. They are essentially monitoring what happens on chain, and as soon as they see a bundle, they all jump on it and apply for it, like, hey, me, can I host it, can I host it? And what happens then in the smart contract, it selects a certain amount of Atlas nodes that get selected, and you will be storing that bundle, and you will earn a small, you will be rewarded periodically a small fee for hosting that file over time. And of course, the smart contract and others are watching to make sure that at no point you disappear with a bundle, otherwise you not only don't get paid, but also you are staking. So essentially you might lose your stake if the bundle is not available. Now what happens is you can build anytime a simple application or a dApp that first gets the data, the actual data, regardless if it's private or not. You would have access to that data if you're allowed, in a centralized way, in the gateway. Then second, you can get the metadata to verify the data you just got from those bundles, and you can, obviously, once you get the full bundle or just a chunk, you can verify if it corresponds to the root that was stored into the blockchain. So that's essentially it. Thanks. So just a very small use case that you can build. Once you have such a system, it becomes very, very easy to implement all sorts of applications. So one example would be transporting, for example, vaccines. So vaccines need to be stored at a very specific temperature. So the first thing you would do is that every single vaccine pack would get a unique identity. That identity will go in one of those bundles, and then you can seal the physical product with an RFID tag being linked to that identity. You put all of those boxes into a cold case. You can put a sensor, as I mentioned, inside that cold case. You close it, and then you transport it all the way to a pharmacy, for example. The sensor monitors the temperature. It also can verify if someone has tried to open the box or if someone removed or put back one of those boxes, so that when the pharmacy receives it, they can open the box, they can look at the inventory, is everything there, and they can take every single individual pack, verify, okay, pack number 3, was it the genuine one, or has it been changed by or replaced by another pack? And this, they can verify all of that with the application, for example, the dApp I mentioned before. And likewise, the end consumer goes to a pharmacy, just buy a vaccines or some insulin or whatever it is. They can buy the pack, and themselves they can verify as well if the pack they have is authentic, is it really the right one, and also because it's going to be linked to the temperature in which it was transported, and they can see the entire history, they can also verify, okay, has this pack of medicine been stored at the right temperature? I mean, is it still effective, or should I not buy it? So, you know, just the takeaway here, the first point is what we have observed by building this system, is that the combination of one single public ledger combined with those different decentralized data storage nodes and those gateways are a very effective way to scale to the global IoT-like scenarios, where you can have billions of devices connected to each, sharing data with each other. The second point is data interoperability is going to be one of the most fundamental challenges. So until we solve the ability for any device or application to kind of talk to each other in a universal Esperanto, it's going to be very hard to build one single global scale IoT system. The third point is blockchain security, and the level of security that we see every day in blockchain technology is not yet very common in IoT systems, and that definitely needs to change. And finally, the whole developer tooling, the whole SDKs and everything you give to developers is really important, because that's really going to make a difference. The easier you make for your developers to start building, combining the blocks, build and operate apps, the more successful we are going to be. we as you, everyone. Cool. So thanks a lot, everyone, and happy to talk with you after that. So thank you.
Thank you. So you actually said something quite interesting, because recently I've been working with a company that's looking to put a chip, a sensor into solar panels, so that they can have like really granular data that's coming off it. And the financiers are saying that, well, if we can actually monitor how the solar farm is doing, then that'd be very interesting. We don't need to trust the data that's been provided by people operating these farms, and we can actually monitor it and know that it's correct and
That's an
real,
interesting point. Yeah, I mean, the same principle you can apply to any use case, essentially. You just need to have a way to measure real data and trust it. And that's why, for example, we enforce a lot signing every single sensor reading on the device itself. So even if it passes through untrusted operators or other systems, then you know for a fact that the data was signed in hardware, like hardware wallets, essentially, but for sensors.
Yeah, so just really quickly, what do you think is the biggest challenge in combining IoT with blockchain technology?
I think it's two different mentalities or two different worlds historically, but I think there are lots of things that are in common, such as data management and especially security. Each side can learn from each other, I think, a lot. So really the cooperation and seeing more and more projects that get very closer to hardware, that get very, very close to embedding blockchain technology directly on chips. That's not easy, but I see more and more projects that are exploring and making it all work at scale. That's the challenge.
Great, thank you.
Thank
Appreciate
you.
it. Thanks.